Hi folks, we're going to take a look at page 443, number 37. So let's take a look at the question. It says that the height of lava ejected from a volcano is modeled by this equation, okay, where h is the height in meters of the lava above the crater and t is the time in seconds since it was ejected. Okay, so graph the relation. So we take a look at this here, and I see that it's in factored form. So factored form allows me to find the x-intercepts very easily. So okay, I'm going to be very explicit here. So h is equal to negative 5 t times t minus 11. Normally I wouldn't necessarily show this, but just as a reminder, so if I replace h by 0, remember how this works. The idea is that I've got three things that multiply to 0, so one of them needs to be equal to 0. Obviously negative 5 can't be equal to 0, so either t is 0 or t minus 11 is equal to 0, or t is equal to 11. Okay, so these are the x-intercepts, but if I want to graph this a little more, with a little bit more precision, I might as well also find the maximum point or minimum point. Now I see here, because of the negative 5, it's going to be a maximum point. And I also noticed that in parts B and C, they ask me about when the maximum is going to occur. Okay, now again, there's lots of ways to do this, but since I already have the x-intercepts, I might as well use the fact that the h value of the vertex, or the x value of the vertex, is just given by the average of the two x-intercepts. So 0 plus 11 divided by 2, so that's 5.5. And then if I want to find the y value of the vertex, I just have to now input that into the equation. So negative 5 times 5.5 times 5.5 minus 11, which is just going to be negative 5.5. Okay, so let's put that in our calculator here. So negative 5 times 5.5 times negative 5.5 is equal to oh, sorry, I just realized I made a mistake here. I inputted this incorrectly. See, I should have just inputted exactly as I wrote it. Okay, so a little life lesson there. Negative 5 times 5.5 times, and I'll just write it 5.5 minus 11. Okay, avoids making a little silly mistake there. So this is 151.25. All right, so now I've got my vertex, I've got my x-intercepts. I can draw a fairly nice graph. Okay, so I'll draw it here. And I'm not going to go crazy being perfect. Okay, so I've got 0, I've got, say, 11, so somewhere in between is 5.5, and so let's say this is my vertex, so say this is 151.25. Since it's the only y value I'm going to choose, I can put whatever I want there. So let's try to draw this. Okay. Okay, now they just asked me to draw the relation. So question is what's my domain? Well, it makes sense that t will never be less than 0. So I'm going to start it here. Now you might be wondering, why did I draw this continuing to go down? Okay, well this is because I noticed something very interesting. It says that h is the height in meters above the crater. Okay, but if you think of what say I've got a volcano, it's like a mountain, so this is going to spew out, okay, but the height of the volcano or the crater is there. This is likely going to keep going down below it. So this is one of those scenarios where we might want to consider negative height, because we're considering a height above the crater, whereas the crater is a mountain, so it's going to go down below that. Okay. So just a bit of an interesting thing in this question. So B, let's take a look what they ask us. We'll find the maximum height reached by the lava. Well, we already got that. It says to the nearest meter. So we'll just put 151 meters since we already found that. And in C, it says how long does it take the lava to reach the maximum height? Well, we can see right from our graph that's going to be exactly our x value of the vertex. All right. And so that takes 5.5 seconds. All right, and then D says, is the length of time that the lava is in the air twice the answer from part C? Explain why or why not. All right, so this kind of comes into play with my little drawing here, that if the lava was spewing out from the ground, going up and then coming down, then I would say the answer would be yes. But because we're measuring the height from the crater, which is above the ground, it's going to reach, this would be 11 seconds, okay, on our graph when it comes back down to the height of the crater. But presumably it's going to keep going down until it reaches the ground. So in this case here, I'm going to say likely not, since the ground should be below the crater. Okay. Now, this is not necessarily the case. Some volcanoes are actually right at the ground, but most of the times when we think about volcanoes, we think about mountains that have these openings, which the lava flows out of. All right, so just do a quick recap here. So step number one, to answer part A and even B and C, I used the fact that this was already given in factored form, so I was able to find the x-intercepts. From the x-intercepts, I can find the x value of the vertex, which is just the average, and then the y value, I just input that into my equation. And then I was able to graph nicely, answer B and C. And then part D, well, we had to make some assumptions as to what this volcano would look like in order to answer that question. Okay, that's it for this one.